In this video, we'll continue our discussion of polar integration by doing another example of finding volume. So we have this double integral of the surface negative y squared over this region. Now, this region is a little difficult to get to, so I'm going to show you how to get to it. Here's the picture of it. So it says it's bound in Q1. Cool, we have that. It's also bound by x equals 0. That is our the y-axis, straight up and down. So it's bound by that, Q1. And then we know what this is. That's just that blue line. Now, this thing, you may not be clear of how that's a surface. So I'm going to walk you through something real quick. I want to show you something silly for a moment that's going to help with understanding how to complete the square. That's what we're going to have to do. Bear with me. This is going to feel like it's kind of silly, but it's going to make a whole lot of sense here in a moment. I can multiply these binomials by doing an area model. I can do x plus 3, x minus 2. And then just multiply the insides by multiplying the sides. So multiplying the sides, I get that, meaning that I can just add this x squared plus x minus 6. All right, the reason I'm showing you that, let's take x squared plus y squared and equal 4x. Okay, let's take that, and I'm going to show you how this is a circle using that box model to complete the square. So I'm going to minus 4x from both sides. So I'm going to minus 4x, I'm going to put a space here. Then I got plus y squared, and then I'm going to put a space on the other side. It's a 0 right now, so I'm just going to put a space. What I'm going to do now is use this whole area model thing to help us out. Let me make this a little bigger so we don't have to shove it in there. Okay, I know if I'm working backwards, I'm trying to find the outsides of this box. I know this is x squared. We're working backwards. Minus 4x can be split. I'm going to do it in half to make here because we're trying to complete the square, meaning I want to make a square. Well, the only way this is going to work out is I put x and x there. That's the only way I'm going to get x squared. I split negative 4x to negative 2 and negative 2 because I want it to be half, because now this has to be a negative 2 and that has to be a negative 2. This is creating a square. So the whole process, and I feel like algebra teachers cheat people out of seeing this, we're going to complete the square by filling in the last box. Negative 2 times negative 2 is 4. That is what goes in my space. But I can't just add things to equations. I got to add it to both sides. So I got a 4 over there. But what's great now is I can use that box to factor that. The outsides of the box, it's x minus 2 times x minus 2 plus y squared equals 4, and then you can kind of see where this is going. I can put these together. Now this tells me it looks like a circle. This moves to the right 2. It moves it to the right 2. So I have a circle with radius 4, and it's moved to the right 2. So you can see that my center of my circle is right there at 2 to the right on the x-axis, and it has a radius of 2 in both directions. So that's what we get there. All right, I'm going to erase all this because I need the room. But that is completing the square using an actual square. Like I said, I wish algebra teachers would do the justice. I hope yours did. I know I do in my algebra classes. But if not, that's how you complete the square. All right, so we deleted all that. Let's move forward now. We're going to rewrite this. We have our integral up here. And we are going to come up with our bounds. I can see this is circular. The problem is trying to find, we're going to try to bound r. Well, r changes. Let me grab something I've used here. Black, sure. It changes. So this goes to here, but notice that r goes to there. It's a lot different. It changes as it goes through. So it's not going to be r's caught between two values this time. It's going to be r's caught between, okay, well, I can see it starts at 0. The origin is in the region. So I know that. The problem is I got to get to that other side. Well, we can use this circle to put it in terms of r and theta. So I'm going to replace everything here. X squared plus y squared is r squared. Keep my 4, and then I know x is r cosine theta. I just replaced it. Notice that everything has an r. There's an r on both sides. I'm just going to cancel that out, leaving me with r is cosine theta. This will describe how big r gets given the angle. So I know r is caught between those two. we also have to have theta. Okay, well, theta is a little difficult to come up with. Theta is an angle, and I can determine an angle using tangent based on an x and a y. Well, I know that line there. I'm trying to find what angle that is. That is going to be a slope of 1/2. That's y over x, right? Goes up 1, goes over 2. And then I know that theta then is the inverse tan of 1/2. It's not going to be pretty, so we're going to use that the whole time. So that tells me that theta is between 0, or actually, be very careful here. It starts on that blue line, so it's going to be the arctan of 1/2, sorry, forgive me, of 1/2. And that is in between that and pi over 2. All right, so we have now that is bounded. So now we've done the setup part. All we have to do is the integration. I'm going to move this over because I know I'm going to use the room. All right, so let's start this process. I have the integral, and we're going to change negative y squared to negative r sine theta squared, and then r dr d theta. I have r is between 0 and 4 cosine theta, and then theta is not pretty. It's between inverse tan. So let me just get this over. Inverse tan of 1/2 all the way up to a pretty angle of pi over 2. That's straight up and down. That's why we have that. That's right here from there to there. Right? Inverse of whatever that is. I just didn't plug the inverse of 1/2 because it's going to give me a decimal. So I'm just going to leave it there and then in the end deal with it. All right, so there's my integral. All right, so I got theta. Let's go ahead and start working this out. I'm going to simplify everything that I can. All right, so I have that. R is 0 to r equals 4 cosine theta. Integrals take so much to write down. Okay, that negative is going to be there. I'm going to have an r squared times an r, so it's an r cubed times a sine squared theta. I see that square, so I'm probably going to use the reduction formula at some point. I wrote that down at the top. If you go, here we go. That's it. We're going to use that here in a moment. So first, let's go ahead and we can actually integrate our first r's. Inverse tan of 1/2. I'm just rewriting here. All right, let's go ahead and take our integral. That's going to be negative 1/4 r to the 4th sine squared theta. Nothing changed there. And I'm going to run 0, r equals 0 to r equals 4 cosine theta. And then I have d theta left. All right, just rewriting now. All right, we're going to plug our r's in. Okay, so they're just going into the r. The 0 is going to make it go away, so that's nice. I'm going to go ahead and pull out that negative 4th to make my life a little easier. We're probably going to end up having to change it again. But now I'm plugging 4 cosine, so that means I got 4 to the 4th, which is 256. 256 times sine squared theta. That's plugging in, oh, we forgot the cosine. So we got to plug cosine. We're going to have cosine to the 4th theta, and then sine squared theta. I wish that cosine wasn't there. It would make our life easier. So that's plugging in 4 cosine into r. Plugging 0 would just make it go away, so now I have a d theta. All right. I'm aiming to use the reduction formula here, so I'm aiming just to have sines. So I'm going to replace my negative cosine to the 4th. I'm going to do a little trick here. All right, write down my bounds, so just rewriting. So much rewriting. All right, and then I got 256. Oh, let's bring that 256 out. Let's go ahead and take care of that. Okay, that's going to be a negative 64 out front then if I pull the 256 out. Cosine, I'm going to change it to cosine squared theta squared times sine theta squared. All right, I'm going to do all this off to the side for a moment so I don't have to do it, rewrite my bounds every time. Okay, so cosine squared theta squared times sine squared. I want to get this down to all sines. I can replace cosine squared with 1 minus sine squared times sine squared. Then we FOIL or box, however you think about that. I got 1 minus 2 sine squared theta plus sine squared, or sine to the 4th, squaring that. All this is still times that sine squared. All this work, I just distribute the sine squared now. So I got sine squared times 1 minus 2 sine to the 4th theta plus sine to the 6th theta. It's not pretty, but it works. Okay, that's d theta there. I'm going to rewrite now, replacing that inside with this. All right, rewrite my bounds. All right, and I know the inside is sine squared theta minus 2 sine to the 4th theta plus sine to the 6th theta d theta. Okay, now we can use the reduction. I'm just going to leave the negative 64 out completely and then just do each one separately. All right, so the first one, I'm just going to use the reduction formula because we have it. The 2 goes on the bottom. I got negative cosine theta sine theta because I go down by 1. I'm going to put these in parentheses to kind of help. I got minus 2. Now we're going to do sine to the 4th, so it's over 4. Here, let me get rid of those parentheses before we know. I'm going to have negative cosine theta. Sine, it was to the 4th, so this is going to be to the 3rd. Over m. M in this case was 4. All right, let me shrink this down because I'm going to run out of room. Gosh, I keep missing things. There we go. And then plus, and then this is a reduction formula with the 6. I got 6 over negative cosine theta sine to the 5th theta. All right, all that is ran with the thetas that we came up with. Let me shrink this down again. Looks like I just lost the dot of I on that sine. This is going to now be ran between theta equals tangent, arctan of 1/2, and theta equals pi over 2. Okay, at this point, I would use a computer. That's a lot of stuff to plug in, and it's disgusting. The pi over 2 is not too bad, but plugging in an arctan and having to do those trig problems for every single one of those, and it's doable. We can do that. It's just using, once we plug inverse tan into the sine, you draw a triangle with tangent, you find the third side, then you find sine. It's not that big of a process, but that's a giant trig topic that I don't want to use video time on. So at this point, I could just plug them in and stop. I'm going to write down the answer for you in case you want to really work it out and get to the end. Assessments, I'm pretty, things are a little more manageable than this. I'm looking for concepts and stuff like that rather than these giant problems. This ends up being a 2, by the way, which is very strange. Let me check my Wolfram Alpha to make sure I plugged that in. Oh, no, I did it. Hold on one sec. I actually may need to rewrite this answer. I'm glad I checked. Give me one sec. Okay, so click this. Give me one sec. I'm just pulling it from Wolfram Alpha. It's a great program to get to an answer. Let me get down to the bottom. Oof, these are a lot of steps. Here's the answer, not what I just wrote down. Thankfully, I just caught my little mistake in my typo in Wolfram. So here's the actual answer to that. Nothing else is wrong there. I got 104 over 375 plus 2 pi minus 4 arctan of 1/2. There we go. I plugged in the wrong, I plugged a 2 there instead of the 1/2 when I was working the problem out. This is roughly, if you wanted to keep going, that's roughly, I think I have an answer at the top here, roughly 4.7059. All right, I think all that's correct. Let me double check that. It flipped my bounds on me. Oh, okay. So actually, the answer is going to be the negative of that. Hold on one sec. Wolfram's doing some weird stuff to me. Let's do this. Hold on one sec. 2 pi over 2. I'm just plugging this in. I'm using my computer because the iPad doesn't handle it too well. I mean, I guess it does. I just don't like it. All right. Oh, there's a typo. One sec. A lot of you guys may have belled already, and that's okay. All right, cool. I have it. Let me just click this button so it'll show me all of it. All right. So third time's the charm. Let's rewrite this. I'm glad I'm catching it now, not having to re-record. Please forgive me on this. Typos go a long ways, unfortunately. So let me make sure this one is set up correctly this time. Now it is. It's just going to change to negatives. That's all it's going to happen. So if you haven't erased, just change everything to a negative. That makes sense. Our bounds were just upside down. That's all it was. All right. So that same thing we just wrote down. And then this is approximately negative 4.7059. Remember, volume can be negative. Think about it. I'm sitting in a room right now. If I were to fill this room with sand, I'm a negative volume, right? Negative values when it comes to measurements really is just produced from a perspective, right? If the volume in this room, the perspective of the volume, I'm taking up space. So volumes can be negative. Sorry for the few typos there at the end. Again, in your work, you're going to do stuff like this, but like on assessments, I'm not going to make it that bad. Maybe your feedback quiz, because you can work that out and figure it out and come ask me questions. But like an assessment on a test, if I give you something that ends up like this bad, I have to stop, plug your thetas in and stop. Because you're not going to have a fancy calculator CAS to do this for you. But like I said, I keep my integrals and all that stuff decently tame on my assessments.